All right. So here we have a table from number 14 and 16.1, and they've given us some estimates for amount. They want us to calculate the total volume of mosquito larvae or something in the swamp, right? Okay, which is oddly applicable here. Okay, so first things first, I just want to know about the rectangle, right? So draw yourself the thing you're trying to integrate over. Okay, so here's a rectangle I'm trying to integrate over. In the x's, this rectangle goes from what to what?
0 to 8.
0 to 8, right? Okay, and then they also told me about 4. And then in the y's, this thing goes from
0 to 6.
0 to 6. And then they also told me about 3, right? Okay, so looking at this, they've split this into 4 rectangles, right? You guys see that? Now I want to know what's the highest or lowest, right? I want to do an upper sum and a lower sum. You guys all cool with that? Sure. Okay, so let's calculate an upper sum and a lower sum. So sum lower, right, is going to be, okay, well, I'm going to have a, what's my change in x?
4.
4. What's my change in y?
3.
3. Okay, and then what's my height in each piece? So from 0 to 4 and from 0 to 3, what's the lowest value you see? So that's looking in this little box, right? The lowest value in that box is 1, so I'm going to use 1, right? That's that, right? When I look at this, I'm thinking top left. Then I'm going to add, okay, which one am I going to go to next? Sure, whatever, pick one. Lower left.
2.
Okay, so in the lower left, I'm looking at these 4 values, so 2 is the smallest one. And then I want to think about upper right. And so that's these guys, right? That's x's between 4 and 8 and y's between 0 and 3. So that looks like 3. And then,
And 5 for the last one since it's the,
yeah.
the lower right.
Yep, perfect. So lower right, that's these 4 values. So the smallest I get is 5. Okay. How about an upper sum? That's going to be,
Still the same, 4 times 3.
okay, still 4 times 3 times,
5.
where'd you get 5?
In the top left, it's the largest one.
That's kind of these 4, right? So x values between 0 and 4, y values between 0 and 3. Biggest we can be is 5.
And then number 9, 9, 15.
9, 9, 15. Right, and that's not necessarily because, right, this thing is these 4, and this thing is those 4, right? It's really at each stage I'm picking. My complaint about your book is that the units they use here don't make any sense to establish without already sampling an area. Because they're saying the units on these numbers here, right? They're saying those units are milligrams of mosquito larvae per meter squared, right? But how did you get that number? You couldn't establish that at a point, right? You guys see that?
Yeah.
They needed a function height, and they kind of mismanaged their function height, in my viewpoint. Cool.
So
to
this,
pick, oh, go ahead.
I was just gonna say that system's probably better when we have a huger table than, because you could basically get almost the exact same value by just doing the 4 minimum, 4 maximum.
Yeah.
Okay.
Yeah, but when you have a big table or a table that's like this table is consistently increasing from top left to lower right.
Because we had a pretty big table on one of our other questions that was.
Yeah, and if the
very-
table's bigger, you definitely can't just pick the lowest 4 values and the highest 4 values.
Okay.
Or even on this one, right? If I changed this number to 1, right?
shouldn't pick the 1 for the.
Then
Would you do the 3,
Then you would
6,
pick
5,
Oh.
9?
2 9s.
2 and 1.
Yeah, I'm sorry.
Mhm.
Suffice this to say, if you fiddled this table around a little bit, you
Mhm.
could get these to change from lowest 4 to highest 4.
So what if that was 1? Can it not be 1?
Yeah, so if this was 1, that would change this number and this number, right?
Because.
Because in my lower 4, right, I would have the option of picking a 1, which would be lower than 5. And I would also have this option of picking a 9.
Even though there's 2
Oh, which I
9s.
guess would actually
can't-
change my... Yeah. So if I change that to 1,
So you would choose
then
1.
my lowest 4 are still the same, right? But my estimate for my upper is no longer the... What the hell did I put a 1 there for?
Because you were in the middle of putting a 9 and you just put 1.
Yeah.
How would you get a third 9? There's only 2 9s on
So that's 1 from here,
that.
this block, 1 from this block, and also a 9 from this block.
Okay.
You guys see that? So this one, of course, doesn't have that pick the highest 4 values, right? Because the highest 4 values would be a 4, a 5, and 2 9s.
If the table was 4 times that size, could the block be of 9? And then we choose the minimum of the 9, or would it be better to do smaller segments of 4?
Oh, so if the block were way bigger?
If like the block up in the
Yeah,
green
so
is the size of that whole table,
So if we added a bunch of cells.
yeah, and they just kept going, could you do?
Yeah,
a 9?
then of course you need to pick a subdivision size,
Okay.
right? And of course you could choose your delta x to be bigger and still use 4 blocks. Or you could choose your delta x to be the same and use more blocks. Right, but it depends on what you pick your delta x to be.
So for the lower one, you don't necessarily have to be in that left-hand corner. You can jump over to the other corner and use that other one.
So for this lower corner, right, I'm looking for 4's less than x is less than 8, right? Or equal.
Okay.
And the y's are between 3 and 6. And so
Okay.
then I go over to my table and I think, okay, if y's are between 3 and 6, that's this stuff. And if the x's are between 4 and 8, that's this stuff. So I have to pick a number from in here. What's the biggest number in there? 9 goes in my upper sum. What's the smallest number in here? 1 now. That goes in my lower sum.
Or, yeah, sorry.
Okay.
Does that kind of make sense?
Yeah. Just kind of.
Yeah, it's weird to do these with a table. It would make more
Yeah,
sense if
I'd
I
rather
drew this
say
as a
graph.
surface, right?
Yeah.
If I was drawing this as a surface, this 1 would be the lowest corner of that piece, and the 9 would be the highest corner.